Hello class, so today we're going to be learning on how to find continuously compounded interest. Okay, so let's begin. Our function for continuously compounded interest is going to be a equals pe raised to the r times t, and so that's just a equals pert. So a is your amount after time of t, p is the principal or the initial amount, r is the interest rate, and don't forget it has to be in decimal form, and t is time. So let's jump right into our first problem here. So example 1, a man invests $1,200 into a bank with a 6% interest rate compounded continuously for 10 years. How much money will he have after the 10 years? So let's set this up. So A is going to be equal to, and then P is our principal, which is the $1,200. So we'll write that in. And then E, and then R is our interest rate in decimal form, which is going to be the 6%. So we're going to write 0.06, and then we're going to times that by the 10 years. And after solving all this into your calculator and plugging it in, A is going to be 2186.54 dollars.
In the next example, it says someone invests $500 into a bank with an interest rate of 8% compounded continuously. How long will it take for his investment to double? So going off this, it's not like the last problem where you're solving for A. This time you know A, you know your P, you know your R, and you're looking for your T. So it says how long will it take for the investment to double? So you automatically know that A is going to equal $1,000. And set that equal to the principal, which is 500, times E, to the R, which is 0.08, which is the percent in decimal form, times T. And you're going to be wanting to look for that T. So the first step to solving this is you're going to want to take the 500 and get rid of it. So you're going to want to divide both sides by the 500. So once you do that, you'll get 1,000 over 500, which is just 2. So it'll be 2 is equal to E to the 0.08 times T. So now after that, you're going to want to use a natural logarithm to cancel out that E. So you're going to take the natural logarithm of both sides, and you'll get the natural log of 2 is equal to 0.08 times T. And now all you're going to want to do is you're going to take ln of 2 divided by 0.08, and that will equal your T, which is 8.66 years. And that's your answer. So in this next problem, it's going to be very similar to the last one, except this time you're going to be looking for the interest rate. It says someone invests $10,000 into a bank for 25 years. At the end of the 25 years, they're left with $28,000. What was the interest rate if it was compounded continuously? So in this case, we know our A, which is 28,000. We know our principal, which is 10,000, and we know our time, which is 25 years. And we're going to be looking for the interest rate. So first thing we're going to do is plug that in. So we get 28,000 is equal to the principal times E raised to the R times T, which is 25 years. So like in the last problem, all we're going to want to do is we want to get rid of that constant out in front of the E. So you just take 28,000 divided by 10,000, which is 2.8. That is equal to E times R times 25. So now what you're going to want to do is you're going to use the natural logarithms again. So you can take the natural logarithm of both sides. You'll get ln of 2.8 is equal to R times 25. And then all you're going to do is do the ln of 2.8 divided by 25. that'll get your answer, which is 0.0411 and then 85. And that's a decimal form. We want it in a percentage. So all you do is you move the decimal place over 2 places, and if you round up, you'll get 4.12%. That's your answer.
And thank you for tuning in.